Okay, we're going to finish chapter 3 with section 3.4. Which deals with combinations and permutations and the probability associated with them. The first thing we need to do is look at what the difference is between a combination and a permutation. When you're given a set of people or units or subjects and you want to arrange them, if the order matters in how they are arranged, then it is called a permutation. For example, if you have rankings, first, second, or third, or if you're holding different offices, president, vice president, secretary, the order matters that the people are selected in, and that is called a permutation. A combination, the order does not matter. So in other words, if you have 12 people and you want to select 3 of them to a team, then it doesn't matter what order they're selected in. But if you wanted to select 3 of them to hold office, then the order would matter. That's the difference between a permutation and a combination. If you look at the formula for a permutation, and these things can be found in your calculator under math. At the top, you go over to PRB, which is probability. Number 2, you'll see NPR. And number 3, you'll see NCR. Obviously, the P is for permutations, the C is for combinations. So there are N objects taken R at a time. And they must be put into the calculator with whatever your N value is first, and then your NPR, NCR, and then you put in your R value. So let's look at an example. If I have 10 people and I want to put them in order, then we have all 10 that we're going to use. This is a permutation because we want to look at how many different ways these 10 people can be put in order. Well, if you're selecting from 10 people, then there are 10 options for the first slot, but then there are only 9 people left for the second slot, and 8 for the third, and 7, and 6, then 5, then 4, and 3, then 2, and then 1. So this is kind of like the fundamental counting principle. There are 10 options for the first level, 9 options for the second, and so forth. This is called, the way this is multiplied out, another way to look at it is 10 factorial. This exclamation point means factorial. And factorial means you multiply the value by each number below it. So if I'm going to order all 10 people, 10 times 9 times 8, so forth and so on. If you want to use your calculator to do 10 factorial, you'll put in 10, then hit math, go over to PRB, hit number 4, which is the factorial button, unless you want to multiply it all out by hand. So 10 factorial would equal 3628800. So there are 3,628,800 different ways to arrange 10 people. But let's say I'm going to continue this example with the 10 people, but we only want to select 3 of them. For a team. Because it doesn't matter what order they're selected in, well, let's look at what happens when order matters first. To hold office. President, Vice President, and Secretary. So since the order matters, I'm sorry, I did go back and change this. So now we're going to do the order matters. Therefore, this is a permutation. In essence, what we're going to be doing is 10 people for the first option, 9 people for the second, and 8 people for the third, which gives you 720. But there's a formula that goes along with this. If I have 10 people and I'm doing permutations and I'm going to take 3 at a time, then I can do n factorial divided by n minus r factorial. So what happens well, 10 minus 3 would be 7. So all of these end up canceling each other. And I'm left with what I said originally, 10 times 9 times 8. But that's where the 10 times 9 times 8 comes from, is from the permutation formula. So if I put in 10 and then go to math, probability 2, and then put in the 3, 10, math, probability, select number 2, which is NPR, and then I put in 3, that also gives me the 720. Because the calculator is actually working out this formula for you. So I'm going to take this one step further and say I have 10 people. We're going to select 3 for a team. And therefore the order doesn't matter. And we're talking about a combination. I'm actually going to do this a little backwards. I'm going to show you what happens in the calculator first, and then talk about where the answer comes from. So if we do 10, and we do math, go over to PRB, select number 3, which is NCR, and then choose 3, we only get 120. So if you ask yourself, why is it so different, 720 versus 120? Well, the reason is because if I choose 3 people, I can arrange them in 6 different ways. Those same 3 people can be arranged in 6 different ways. So what the combination formula does is it takes your permutations and then it takes out the number of repeats. So if I take out the 6 ways that every 3 people can be arranged, well, that would give me the 720 divided by 3 times 2 times 1, which is 720 divided by 6, which gives you the 120. So this extra r factorial, the r factorial accounts for this, all the possible ways the same R objects can be arranged. So you're taking out the repeats when you divide by that R factorial. Now, there are going to be a couple of other special types of problems. For example, let's say we have 15 people, and of those 15, 6 are male and 9 are female. And we want to have a team of 5 with exactly 2 male and 3 female. So you ask yourself, is this, first of all, a combination or a permutation? And the answer to that is it is a combination because it's a team. But it is a specific makeup of the combination. So if there are 15 people, 6 are male and 9 are female, and I want 2 of them to be male, then I'm going to take my 6 males and select 2 of them. And if I have 9 females and I want exactly 3 females, then I'm going to take my 9 females, and select 3. And so in this situation, I would need to put this in parentheses in my calculator. So I have 6 things selected 2 at a time times 9 things selecting 3, and that gives me 1,260. If this had been a situation where you would need the order to matter, like they were holding specific offices, then you would have to do permutations instead of combinations. The last thing I want to address is probability. associated with permutations and combinations. So remember that probability is equal to the number of successes divided by the total number of outcomes. That doesn't change just because we're talking about combinations. So if I wanted to go back to my same example up here and say I have 15 people, 6 male and 9 female. I want a team of 5. And say, what is the probability of having exactly 2 male and 3 female? Well, we already know there's 1,260 possible ways that you can have exactly 2 males and 3 females. And that came from 6 males, taken 2 at a time, and 9 females, taken 3 at a time. But then I have, that's out of the total possibility of 15 people and selecting 5. So we already know that top number is 1,260. The bottom number, if I have 15 people and I'm going to select 5 of them, that's 3,003. So my probability of this happening would be 0.4196. So that kind of associates probability that we've been doing in this section with looking at combinations and permutations. And that's the end of chapter 3. The next video will go over the document, the chapter 3 portion of the module 2 document.